All right, in our next example, we're going to analyze reasonable domains and ranges. So part A, a function can model each situation. So we're being told that it's a function. That's great. What is a reasonable domain and range of each function? So here, our first example, a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So we're asked to identify a reasonable domain and range. So a reasonable domain, in this case, the domain is going to be what's happening. As time passes, we are filling a swimming pool. So the number of minutes that have passed determines how full the swimming pool is. So our input is time. That's going to be our domain. And the output is how full the swimming pool got. So the gallons that we have filled, maybe I'll write this. So the minutes, that's the domain. Our output is the range, which is the gallons. So what's a reasonable domain if we're talking minutes? Well, time isn't just any old number that exists. You can't measure time in negative values. Your time can start from 0 minutes. And in this particular example, it will take until the pool is filled. So a reasonable domain is from 0 minutes to the time it takes to fill the pool. A reasonable range. Now the range, we're talking about how many gallons in the pool we can have. So you can't have negative, we don't measure gallons in negative numbers, so we're not going to include our negative numbers. You can fill 0 gallons all the way up to, this one has a cap, it goes up to 10,000. So our range is going to be from 0 to 10,000 gallons, which is the capacity of the pool. All right, so let's look at a reasonable domain and range for this example. The restaurant needs to order chairs for its tables. One table accommodates 4 chairs. So if you have 1 table, you'll have 4 chairs. 2 tables, 8 chairs. 3 tables, 12 chairs. So the number of chairs the number of tables determines how many chairs we have. So in this example, that means that our tables will be the input, which is our domain. That determines how many chairs we have, which is the output, our range. So our domain, a reasonable domain, can we have a negative number of tables? We cannot. Can we have 0 tables? Yes, we can. And then any positives after that. So a reasonable domain would be from 0 to the number of tables needed. All right, a reasonable range. Remember, we just said range is our number of chairs. So for every table that we have, we're going to order 4 chairs. So a reasonable range will be multiples of 4. Starting from, if there's 0 tables, we have to order 0 chairs. We won't have a negative number of chairs, so our reasonable range is going to go from 0 to, well, okay, so it's going to be multiples of 4 from 0 to the number of tables needed. Because remember, if we needed 5 tables, then we'll multiples of 4. 5 times 4, we would need 20 chairs. Okay, so part B is the domain for each situation continuous or discrete? So we defined continuous in our intro video as being the set of all real numbers for the domain. The domain of a function is continuous when it includes all real numbers. The graph of the function is a line or a curve. So here we have a graph of the example of our swimming pool. As time passes, our volume is increasing. We're filling up the pool. So we could have, let's see, 1 minute. Here's how full we are. 1.5 minutes, we're here. I could go to 4 minutes. I'm at 16 gallons. I could go to 4.23 minutes. So because it's every value in between 1 minute, 2 minute, 3 minute, 4 minutes, this is a continuous graph. And I think it makes sense when you look at the picture. The line is it's including every point here. So that is a continuous domain. I think that makes sense when we compare to what a discrete domain would look like. Here we have a number of tables. If we have one table, we're ordering 4 chairs. If we have 2 tables, we're ordering 8 chairs. I can't order between 1 and 2 tables. I can't order a 1.5, so I would not want the line filled in between those 2 values because I can order 1 table or 2 tables or 3 tables or 4 tables. So the domain of a function is discrete when it consists of just whole numbers or integers. And the graph of the function is a series of data points. So here we can see it's a series of data points just plotted on the graph. So the domain of this function is discrete.